Hi, welcome to the Shiko Math Lab and the fun probability problem solving sessions. So let's take a look at what type of the probability problem we are going to work today. Okay, so this problem has three parts. So basically, these problems are trying to let us practice the binomial distributions and the negative binomial distribution concepts here. Okay, so let's take a look at the what are the three parts here. So the first part, part A, they said the two teams, A and B, play a series of games. The team A has the probability 0.4 of winning each game. Is it to its advantage to play the best 3 out of 5 or 4 out of 7? Assume the outcome for successful games are independent. Then the part B said, suppose instead of the games continue until team A, so there's no restriction for 5 games or 7 games, until the team A wins the third game. Then let n to be the capital number, the n is the capital N, be the number of the game played. So total how many games played. Now I want to find p that less than or equal to 5. Then show this has the same value as part A. Well, that's very interesting. All right. So then the C is here, the assuming B, what is the chance that team A has to play at least the A game before, before it beats the team B 3 times. Okay. All right. So now let's go ahead and start to do the part A's here. Okay, here is the part A here. And for this problems here, I like to use the 3 out of 5 as example and to show you the thinking process behind. Okay, so we said 3 out of the 5. So we know the 3, the combination of the 5 and the take 3, this is 10, right? So we have 10 different situations. So let's see here. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the reason why I want to draw this table because when we do the part B, I want to reference back so you can see, the why I draw it. Okay, give you a better visual, the explanation. Okay, so for the win the 3 games, so let's say we have these situations, right? So we have this one, this one, this one. Then we have this one, and this one. Now we also have 1 and here, here. Now we have here. Now we have here and here. Now we have here and here, here. And so here it is, okay. Okay, so here this is, okay. This one's here. So those are the 10 different possible situations the team A can win the games here. Okay, because if after the team A wins the 3 games, the game stops, right? Okay, so in here, so like if you want, you can say, okay, so the probability for this ones here, you can say this is just 0.4 to the what? To the third powers, right? So for these ones here, you can say this is 0.4, 0.4, 0.6, and 0.4, right? So this is 0.4 to the third power 0.6. Of course, you can do this and then just add them together. Okay, so this is 0.4 to the third power 0.6 to the square. Okay, so now for 3 out of the 5, it's not bad. You can write it, okay? So if you say, how about I use the binomial distributions here, right? So in here you say, okay, so I will say this is the 5 to the x, right? 5 to the x, or if you want, you can say if the, so 5 to the 3, so it's a 5 factorial, 3 factorial, 2 factorial, and so you say, okay, probability x equal to 3 here. Okay, so that means you choose 3 wins, right? So this one will be equal to, then you will say it's 0.4 to the 3, 0.2, 0.6 to the 2. Okay, so but this ones here is only cover, that means you have the 5 games, like this is the situation we'll cover. So for the first one, this is a 333, but then these 2 plays, I don't play anymore, right? Because I already wins here. So instead of doing this way, we need to use if we use the binomial concept. So let's think about backward, right? So we have so many different situations. So how about let's think about the backward will just be, what is the probability that A not going to win the game? Okay, so if A is not going to win the game, that means it's the probability the winning is less than equal to 2, right? So that means you will be 1 minus the probability x is less than equal to 2. Okay, so if you are considered this way, and then instead of the consider, because if you use x equal to 3, that means you only take a look at the situation. You played all 5 games here. All right. So now let me say every game need to play. Okay. So like in here, you assume these 2, the first one here is winning, winning, winning. So you assume these 2, you're going to also, you assume it's the losing games here. But then you don't do that because you stop it here. Okay. So now let's take a look. What is these values here? As we know, this is a binomials, right? So we can use the TI-84 calculator to do that. So in here, let me go to the TI-84 calculator and let me show you how do we input here, okay? Okay, so here is the TI-84 calculator. Okay, let's turn that on. So in order to do the x less than, because in here we say this is the x less than equal to 2, right? So this is the CDF. So we use the second bars, then this is the binomials, right? So we say binomial CDF. How many trials? We have 5 trials. The probability is 4. Now, what is the x values here? X value is 2, right? So because this is a CDF. Then in here, so let's see, it's 1.68256. Now I have 1 minus. So I say 1 minus the answer. So it will be 31744. Okay, so that is our probability is 31744. Okay, now let's go back to my province here. Okay, so we just calculate the probability. This will be 0.314, 31744, 31744. So this is the 3 out of the 5. Okay, so the same concept is which one is the, to the advantage. Now we'll do 4 out of the 7. Okay, so the same idea, 4 out of 7. The easy one will be you use the 1 to minus the A will not win. So that means A is have winning less than equal to what? Less than equal to 3 here. Right? Okay, so now let's go back to the calculator again to see what is these values will be. Okay, so here, all right, so let's do the calculator again. So you do a second bars, then you're going down, and then it's a CDF here, right? So now your trials is how many? 7. And your p value, the x value is how many? 3, right? So now you have here is a pointer 71028. So you use a 1 to minus the answer. So what do you have? 2a pointer 2a9792. All right, pointer 2a9792. Okay, let's go back to our problems now. Okay, we just calculated, so that this probability, this will be 0.2a9792. So what is so we know to the advantage is will be you do 3 out of 5. This is kind of like the makes sense. Intuitively, it's true, right? Because you have a smaller probability to win, so you don't want to play too many games. So to your advantage, you want to play the less games. So 3 out of the 5 will be the advantage to the team A's here. Okay, that's good. Now let's take a look at the part B. They said, suppose instead of the game continues until the team A win its third game, then let the n be the number of the game played. So find the probability A n less than or equal to 5 and show this is the same values here. Okay. All right. So now let's take a look here. So this is the, the number is the number of the game till it win the third game. So let's do a kind of the refresh. We talk about this negative binomial distributions here, right? So we know the PDF of the negative binomial distributions will be, the k plus r minus 1, and this is a k. Then I have 1 minus p to the k's power and the p to the r's power. So basically this one is you will get you will get the r's success right after k fails. Okay, right? So that's what is our binomial distribution. So now I'm looking for the probability n less than equal to 5. That means I'm going to play total 5 games, right? So for n equal to 5, then plus probability n equal to what? N equal to 4, then plus the probability n equal to what? N equal to 3, and how about n equal to 2? Well, we know we don't have this chance, right? Because I cannot play 2 games and win. The minimum game I need to play is 3. So that's why for the n is less than equal to 5. So basically it's probability n equal to 5 plus probability n equal to 4 plus probability n equal to 3. Okay, so that means here. Okay, so for these numbers here, that means the 5th game I'm going to win, right? So if the 5th game equal, I'm going to win, that means I'm going to fail twice. Okay, and then the R going to win, right? So for these probabilities here will be, so it's 2 plus 3 minus 1, so it's 4 over 2. Okay, 4 take 2, then this is 0.6 to the 2. And this is 0.4 to the 3. Okay, so now for the n equal to 4, see here, that means the 4th game, right? When the n equal to 4, that means the k, I'm only going to fail once. Then I got 3 wins here. So you plug in back to the PDF. So 1 plus 3 minus 1 is 3. It's 1. All right, so then these ones here, you're going to have 0.6, you're going to fail once, and the 0.4, you 3 times. All right. So now for these ones here, that means I only played 3 games. So what is here? K is equal to what? K is equal to 0, right? R equal to 3. So you plug in the above probability. This will be 0 plus 3 minus 1. So it's 2 to the 0. All right, then it's 0.6 to the 0, 0.4 to the 3 here. So in here, I only, let me show you here. So when you get this one down, so for the combination of the 2, so this is 6, right? And so 3, the combination of the 1, this is 3. 2, the combination of the 0, this is 1. Of course, you can put it into your calculator. So when you input into calculator, you will get the same number, 31744. Yeah, but I don't want you just to look at it. I want you to compare to what we just did. So this is 431. So that means the total how many hands, right? So go back to my previous pages here, like in here, right? So here, this one's here. This will be, so this will be 0.4 to the third, right? 0.6 to the first power. So this one is 0.4 to the third, 0.6 to the square. So this one, so it's 1, 2, 3, 4, 5. 1, 2, 1, 2. So this one's here is the same. This is 0.4 to the third power, 0.6 to the square. So for this one here, I only need to play the 4 games. So it's 0.4 to the third, then the 0.6 to the 1. So this one, I need to play the whole 5 games, right? So it's 0.4 to 3, 0.6 to the 2. This one, I need to play all the 5 games. It's 0.4 to the third, 0.6 to the 2. So this one is the same thing, 0.4 to the 3 and the 0.6 to the square. Okay, so now let's try to write it. So here, okay, so this is the one you only need to play 3 games here, right? So this is the one you only need to play 3 games. Okay, 3 games. So you only have 1 situation. So that is what is this one means here. Okay, so now let's take a look. Okay, so like for here, the only 4 games. So this is the 4 games. This is the 4 games. And this is the 4 games. And 1, 2, 3. Okay, I'm missing one. Where is the one? Okay, so this is the 4 games here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this one is the 5 games. Okay, right, so let's see here. Okay, so this is the 5 game. This is the 5 games. So this is the 5 game. This is the 5 games. This is the 5 games, and this is the 5 games. That's right. Okay, so you count the 4. How many 4 games we have here? How many 4 games we have here? Okay, we have 1, 2, 3. Okay, so back to the here, right? So that is what do we get? 3, 4 games. Then back to here again. So what is it? How many 5 games I need to play? 1, 2, 3, 4, 5, 6. Okay, so that's why it's this 6 here. So that is why they said that this one is have the same results as the as the problem number 2 here by using the negative binomial distributions here. Okay, so I hope that this will give you a better understanding. So why this one matched part A here. Okay, now let's take a look at our part C here. Okay. Okay, so the part C, also we need to use the negative binomial concept. They said, what is the chance A has to play. Here is the keyword, right? At least A games here before it beats team B 3 times. So what is at least A? So that means I'm looking for the probability N is greater than equal to 8. Okay, so N equal to greater than equal to 8. So how I'm going to find that? I can find it by using 1 minus probability the N less than equal to 7 here, right? So the probability less than 7, that means that I can write like this. This is N equal to 7 plus N equal to 6 and the plus the probability the N less than equal to 5. That's right. Okay. We already, we already know this part, right? We already know this probability from the previous. Okay, so this one's here from the part B, we know this probability is 0.31744. Okay, so n equal to 7. Okay, so let's try to think about it one more time. N equal to 7, right? That means what? So I'm going to get the third win, right? So my K is what? My K, I'm going to have 4 fails, right? 4 fails till I get a third win. So this one's here, so it's R plus K minus 1, so it's 6 over 4. All right, so then here this is 0.4 to the third power, then 0.6 to the fourth power. Okay, so then this one's here, n equal to 6. I'm R still going to get a third win. Then the K, I'm going to have 3 fails here. So then this one's here will be R plus K minus 1, so it's a 5 over K, so 5 thirds. So this is 0.4 to the third power and 0.6 to the third power. Okay, so now let's take a look by using the calculator and see what is our values here. Okay, let's put it into the calculator and take a look. Okay, so after we put it into the calculator, I know this number will give me 0.124416. And this number will give me 0.1324. And we are ready from the part B, right? This is from the part B. We already find this number. So you add this 3 and you use 1 to minus it. And we have a 0.4199. Okay, so that will be the answer for the part C here. All right, that's it. And so this probability problem, basically, that's kind of the application of the binomial and the negative binomial. Hope you like the way I solve this problem. Okay, nice talk to you, and let's talk to you in our next videos. Okay, bye.